Okay, let's get started. So last time we talked about project free, and we talked about how we can implement a channel, send and receive operations. Again, like those who are late, I'm reminding about academic integrity, right? So just letting you know, right? So that we run in a tool, and specifically for project one, we're already looking at some issues. Okay. Yeah, so for last time we have send and receive, and we talked briefly how we can implement this. We can use condition variables or semaphores, and it's pretty much produce a consumer problem that we talked about previously. The only exception is that it's a finite message buffer as opposed to unbounded message buffer that we had in the past, in the slides. So make sure you have two conditional variables or two semaphores, so each one for each side, right? So if it's the sender semaphore and the receiver semaphore, or sender conditional variable on the receiver conditional variable. Okay, so the send operation, recall, it ends the message to the buffer. The message can be empty, that means it can be null. If buffer is full, it will block and wait. Receive, remove a message from the buffer. If buffer is empty, it will block and wait. So recall that we can use channels, channel send and receive to track resources. Just pretty much the same way we used semaphores for that purpose, like channel send and channel receive here. And in fact, it will kind of behave like somewhat like a semaphore if you don't have any message, right? So you can basically send a message with null pointer, and that means no message is sent. Okay, so last time, we said that, basics for send and receive should be straightforward, but close can be a little bit trickier, and we'll talk a little bit about this. So and select requires some further, thought how to make it right. So specifically, we need to figure out how to block across different channels. That is the problem for select, because select will work on multiple channels. And you might need to add some additional structs. You may need to modify some functions that you already implemented in the basic version, and so on. So this is why do it step by step. Implement basic version, then go to select. And finally, the unbuffered version for the extra credit, it will be even probably harder. That you only do if you have extra time, right? So once you're done with select. Okay, so last time I also said how we can create a channel. We allocate a buffer, but then you will have this channel structure, channel underscore t. This is where we're going to put a pointer to the buffer, and we're going to put other things like pthread mutex t. So some of you asked, okay, where can I use global variables? No, you cannot, because if you use global variables, that's not going to work appropriately, right? So we need to make sure that this synchronization primitive is only for this channel, not used for anything else. There is no need for any global variables in this project. So all mutexes, all semaphores that you need to have should go to channel T, except for select. We will talk about select separately. So again, you use pthread mutex init, use pthread mutex destroy eventually when you are done with this mutex, and so on. So channel sent, we looked at this last time. Again, we specify this channel, we specify a message that we want to send. Null can be a valid message. It's a finite buffer. If the buffer is full, that means, we can no longer add anything else, right? So we have to block. The opposite is true for channel receive. If the buffer is empty, then we have to block. Otherwise, we can receive some message. And, there is a void double star pointer. Recall that it's an output parameter to just void star. And why do you use a double pointer? Well, basically because you want to initialize data like dereference data equals to result. This is just to remind you what we covered last time. So now we got to the point where we talked about blocking and non-blocking versions. So blocking means we will have to wait, right? So you have to be blocked on semaphore wait or some conditional wait or something like that. Oh, sorry, conditional variable wait or so on. So whatever the operation we use, we'll have to block, right? So that means, let's say we don't have any space in the buffer, we have to wait until there is some space. For non-blocking, that means, let's say I have 5 empty spaces, like empty spaces in buffer, then I can still maybe send 5 more elements. But after this, the 6th sender will come, it will not be able to proceed. So that means for non-blocking version, there is no difference for the first 5 elements. So that should still work the same way as the blocking version. But the 6th one, for the blocking version will block, and for non-blocking version it will return an error. It will say, yeah, I cannot send it right away, sorry. I'm returning the E would block status. So sorry, E would block. E would block is the system error status would block in our project. Okay, do I need to lock non-blocking send and receive? Yes, because it's still the same thing, right? Still the same buffer. So we want to make sure that we have atomic data access. So we want to make sure that it only works correctly if everyone gets a lock, whether it's a blocking or non-blocking version. So whenever we modify any shared buffer, we have to get a lock. So let me actually talk a little bit more about it. And more specifically, let me show you. Yeah, and more specifically, so let's say we have channel send operation and receive operation. So I guess I will give you a hint, right? So it will have some weight on, sender semaphore, something like this, and maybe some weight on the receiver semaphore. Recall that in slides we have seen just one semaphore, but because it's a finite buffer, we have to have 2 semaphores or 2 conditional variables. So now, do I need to get a lock? I mean, it's a blocking version. That means, let's say sender was initialized to 5, 5 senders can proceed right away. So receiver was maybe initialized to 0. That means no receiver can proceed until there is something in the buffer. Again, I'm just giving you a hint, right? So, but now let's say we have we have the 6th thread that's coming, right? So for some weight, it will block here. So what is non-blocking version? What non-blocking version can I use for a non-blocking version of send or non-blocking version of receive? So what should I use for semaphore? So the very first operation will block, right? So what should I replace it for the what should I replace it with for the non-blocking version? Any other ideas? I think somebody in the past mentioned there is a try versions of right? So there is try versions of try wait and so on, try lock, right? Yeah, so just use send try wait. Send try wait. So send try wait will do the same thing for the first 5 threads, just like send wait. So it will the same way did decrement the semaphore and so on. The moment the semaphore becomes 0, instead of going further, it will just return an error. So unlike wait. So, and this is where you would return would block error. So pretty much wait can be replaced with the try wait, and that's what you need for the non-block conversion. So again, in the past, I've seen some people in similar cases, similar assignments, they would use try log or something like this. Don't do try log. Here's the difference. For semaphores, here on the sender semaphore, you may be blocked like for minutes, for days, for for weeks, or whatever, right? For years, if there is other side is not receiving anything. So you can be blocked for indefinite amount of time, right? So that means if the other side is not receiving, I'm blocked here. There's nothing I can do. Buffer is full. I cannot push any more elements because no one is draining the buffer. So the producer cannot do anything. So that means I can be blocked indefinitely. And this is where try wait should be used. So now there is another case when we modify the buffer. And when we modify the buffer, we have to do it in mutually exclusive manner, right? So we have to get a lock, mutex lock, mutex lock, and then we have to do buffer add, something like this, and then mutex unlock. So here you don't want to use try log. So don't use mutex try log here. I've seen some people trying to do something like that. Don't do that. Yeah, don't do try log. It's because the amount of time here is finite. So it means buffer add is just a small operation. I just need to make sure that all threads are executed in a mutually exclusive manner, and that's it, right? So that it's done it's a very short critical section. It will not block indefinitely, just a very short period of time. As opposed to this one, because as I said, it can be blocked for days, for weeks, for years, and so on, right? Just, I mean, of course, I'm exaggerating, but that's the difference between them, right? This one cannot be blocked for years. Sooner or later, your buffer add will succeed, and so it's a short critical section. So this is not dependent on behavior of other threads. It's just to update your buffer. So this is why it's totally fine to use lock here, even though it's a non-block conversion. But here you must use try wait, because this is something that can block indefinitely. Does it make sense? Okay.
Why do we need two different semaphores for sending and receiving? Because can we just have one semaphore where we receive?
Well, there are two conditions. One is the buffer is full, and the other is buffer is empty. Right, so you need therefore you need two conditional variables, so two semaphores. In our slides last lecture, we had only one condition when the buffer is empty, but buffer can never be full because the buffer was unbounded. So for that one, of course, we just need one semaphore, one conditional variable.
So does that mean we should initialize the semaphores to the side, to the capacity of the channel?
Yeah, so for the sender side, right? So, and for the receiver side, of course, if the buffer is initially empty, it should be 0, right? So just think about the initialization values. Yeah, so it's if you use semaphores. Again, if you use conditional variables, it's going to be slightly different, but so the idea is very close. So it's still two conditional variables. Okay. So another thing I wanted to mention is close. So let me actually first let me check this slide first. Okay. So channel close. So the purpose of channel close is to stop current. By the way, can you hear me? Yeah, there's some. I think the battery is bad. Let me replace the battery. Okay, so the purpose of channel close is to stop current of future operations. So that means channel close can still be executed while we have send and receive. But the moment we do channel close, any future send and receive should be kind of failing, right? So they should be returning with an error. So the concern here arises that the current threads, or in fact, any future threads, have to exit right away, right? So they will have to say, okay, the channel is closed. There is no point for me to wait anymore. So let's say I will block for days here, and then finally the channel is closed. You immediately want to wake up and exit. Yeah, so that's pretty much what it is. So the current threads need to exit or like send, receive, and also select. So remember that we have select operation. We haven't talked about this yet, but that also has to be taken care of. So it should return closed error. So that means channels now closed. Please don't add anything, don't receive anything, just return closed error. Future threads should also return a closed error. That means a thread that will arrive a minute later should still return closed error. So the channel still exists until it's destroyed. It can potentially be used by future threads. So you want to add this flag to a channel. You want to add maybe close flag or something like this. And you probably need to modify other functions like sender and receiver. And we'll talk a little bit about this. So what if close called at the same time you had send? Well, how do you need to make that atomic? Because you need to make sure that you get a lock, like whenever you change the close flag, you want to get a lock, right? Because otherwise you're going to have a data race. So I suggest to use the same lock for the close flag that you use for the buffer. So buffer add and buffer remove. So just use the same lock. Because even if you just read the close flag, you cannot just read it without holding a lock, because you can have a data race. Recall that operations can be reordered by the compiler, they can be reordered by hardware, you can get the stale flag or whatever, right? So you always have to do it in a mutually exclusive manner. Whether it's a read or write operation doesn't really matter too much. At least in this particular example. So, okay, so let's see how we can potentially approach the channel close operation. So the channel close sets, by the way, I think I should put on the slide saying like, don't implement it like this, right? So yeah, because it's not fully correct. Channel close, if you set the close flag to 1, so what will happen to other waiting threads? Well, you see, you cannot just check channel close status like this, because again, there is potential data race. So you probably want to get the mutex lock before you set channel close to 1. And then you probably want to check channel closed while you're holding the mutex, just reminding you, right? Because what is going to happen to already waiting threads? So again, there might be a race condition here if you are not holding the lock. So the other concern, whether you want to use a signal or broadcast. So what do you want to use here if you use condition variables for send and receive? Broadcast, right? Because every single thread has to wake up. So what can we use for semaphores? So that's the tricky part, because there is no broadcast for semaphores. So I will talk about this in a moment. Yeah, so, okay. Again, you have to protect it by mutex, because what if channel close is called here, right? So it means you returned, you kind of thought, okay, the channel is not closed, but the channel is now closed, right? So make sure you hold in the lock, because otherwise you have a race condition like this. What if channel close is called right here before you get the mutex and when you check the close status? So you always get a lock before checking the status. You want to make sure that there is a full mutual exclusion here, because otherwise you may mistakenly think that the channel is not closed, but then only finish channel sent when the close is already done, right? So that's not good. So that will cause a race condition. Yeah, so, Okay, so let's talk how we can use. So again, I want to emphasize, I guess I want to change the slide to make sure that you kind of put like, don't implement it like this, right? So don't, because this is a bug here, right? Because there is a race condition here. I want to probably put 3 exclamation marks here. Yeah, so yeah, make sure you're do a correct mutual exclusion. But now let's say we want to use semaphores. For condition variables, everything is simple. You can broadcast, then hopefully you can check the flag on another tab that it's closed and exit. So what do you do with semaphores? So that's a little bit tricky. How do we do broadcast with semaphores? Because we only have samples. Okay, go ahead. Yeah, so we can potentially like increment like 1,000 times or 10,000 times, but it's a little bit hawkish, right? I don't want to kind of do some posts 1,000 times. I don't know how. By the way, I don't know how many threads are blocked right now. I can just randomly, you know, do as many some posts as I can. I guess that will work, but it looks hackier, right? So what? How can I do it better? Okay, so what if I initiate some sort of chain reaction? So if I have, let me erase this one and this. Yeah, so I have close. So what if I initiate some sort of chain reaction? So I have a close operation. I will do same post. Well, of course, I'm going to probably get a log, set the close flag, closed to 1 or something like this, right? So I'll put, you know, whatever, right? So it's up to you to decide. I mean, but reminding that you have to do it while holding the log. Then eventually want to do some post on sender. And maybe some post on receiver. Just one some post. So that will wake up one thread that is sending and one thread that is receiving. So the moment they wake up, again, they will get a log. They will check the if closed status, something like this. If closed. So the moment they wake up, they find that the channel is closed. So if somebody was sleeping, if no one was sleeping, no concern, right? But somebody was sleeping, this thread wakes up and finds the channel closed. So it's about to return closed error. So it will not proceed further. But before it does that, it will say, okay, send post next sender. So it will wake up next sender, and this will wake up next receiver. Next receiver. So it's kind of initiate a chain reaction. So this close operation will poke one thread. That thread will poke another thread. That thread will poke another thread, and then eventually they will all wake up, right? So and whether it's sender or receiver side doesn't matter. So it just do some post. So why is it? It's actually going to work pretty well even for future threads. So what is the semaphore value now? Let's say all threads are done. Semaphore value now is 1. So next thread comes in the future. It's some way it will immediately proceed. Then it will find that the channel is closed and do some post for the next thread and so on, right? So that will take care of any future threads as well because some post has memory, right? So that like it will not disappear. Yeah, so whether current thread or future should be fine. So just initiate chain reaction for here and chain reaction for this one. And that will kind of fall down like dominoes, right? So it will kind of all threads will wake up and will exit. Okay, go ahead.
So when send and receive, like we would post if it's closed, but if not, we would unlock and still post anyway, right? When we're done with send and receive.
Well, if it's not closed, then yeah, then you will not post
at all.
Well, you will post probably on the receiver, right? So eventually, but so you remember that probably you want to do some post somewhere later on the receiver. once you add something to the buffer. But you only do this chain reaction, right? If you are not closed, there is no point in doing this. This is only when it's closed. So because otherwise everything is as normal, right? So just like we described previously. Only if it's closed. So that means on the normal condition, you notify the other side that there is some element there. So you can proceed and, take the element. So now the other thing to keep in mind, when it's closed, I said there is a non-blocking version, tri-weight. So the only difference for some tri-weight, I guess once it's closed, you want to check, I guess if some tri-weight fails, so if some tri-weight succeeds, everything is fine, right? So just the same way as we discussed previously. But let's say some tri-weight fails. So the only thing I want to check the error status. You want to check if the channel was closed, then, just return closed error. Even if it was kind of what could block, it doesn't matter, right? So the channel is closed, so closed error kind of supersedes this would block error. So just when you use tri-weight, you still need to check the status, right, of the channel. If it's closed, you want to make sure you close you return you will return the correct error status. You don't need to participate if it fails in the chain reaction, obviously, because you haven't modified the semaphore, right? So you just, you kind of like, you didn't do any like side effect, so that your thread didn't do anything bad, right? So it didn't subtract anything from the semaphore, so you can just return with an error, and that's it, right? Unlike the case where it succeeds. So when it succeeds, it already decremented the semaphore, and therefore it has to put it back to the original condition, right, when it's closed, so that the next thread can wake up. But if some tri-weight fails, it didn't modify the semaphore, so that means it can just exit right away. The only thing that is necessary to clarify is whether it's a closed error or would block error. Okay, does this make sense? So it's a little bit tricky, but it just, pretty much how you can do the same thing with semaphores instead of conditional variables. So with conditional variables, you have broadcast. With semaphores, you don't have broadcast, but you can still do something like this to wake up all threads. And you don't need to do anything hacky. You don't need to do SemPost for 10,000 iteration, for 1 million iteration. So it will just do exact number of SemPosts that you need. Okay, so what about channel destroy? So there is another operation, channel destroy. It will free memory and destroy objects. So the close operation, sorry, what's going on? The close operation will so the close operation will make sure that it'll just close the channel, all the concurrent senders and receiver will unblock and exit and so on. So that can potentially be executed concurrently with send and receive. Channel destroy is called by just one thread. When you know for sure no one is running anymore, you can deinitialize data, whatever you had, free data, free all these resources. So there is no concurrent receive and send anymore. So you will copy thread mutex destroy. If you had malloc in channel create, you will do free, basically the opposite of what you did in channel create. Buffer create, buffer free, and so on. Pthread mutex destroy, semaphore destroy, and so on. So by the way, don't call sem close, use sem destroy. Because it may be sometimes confusing. That's a different operation. Sem close is a different one. So call sem destroy. So why do we need to do it separately? Because again, close can be executed concurrently with other senders, receivers. In fact, even close potential can be executed twice. All right. So I mean, shouldn't be, but who knows, maybe you can potentially call it twice and then still have to handle it. So you still have to handle mutual exclusion with channel close. With channel destroyed, there is no need for mutual exclusion because only one thread is running. So, okay, now let's get to the, I guess, to the, okay, any questions? Yeah, so now I think so far it was pretty straightforward. Channel send, channel receive. The only tricky part was channel close. Again, just use some flag, use the same lock for the that flag. Always check that flag while holding the lock. Don't forget to unlock it, because another source of bugs when you forget to unlock, don't forget to unlock. Yeah, so, but now the trickiest part is select in this project. Why is it the trickiest part? So the select operation effectively allows you to specify a list of operations. So that's a select D type second argument channel list. So effectively, we're going to say, I want to do on channel A send operation, on channel B, I want to do receive operation, on channel C, I'm going to do send operation again, and so on. And then you are going to specify how many options you give, channel count. So they basically give a list of operations and list of channels. That's going to be an array. And then you're going to specify the array size, channel count, right? And you want to perform just exactly one operation. It's a send or receive, doesn't matter too much, right? So as long as you perform one operation on one channel. And then whatever operation you have performed in selected index, you want to return the index. So you want to say that that operation has succeeded. So please, that's your output value. So select effectively gives an option to execute what operation you want to do. Says, okay, if you cannot send to this channel, receive from another channel, or send to another channel, or something like this, gives options. But we still have to complete an operation. We want to perform exactly one operation, but we must perform the operation, not just say that this operation is available, you can perform it. So it has to actually complete that operation. So the channel list is an array, right? So just an array of remember that we can treat it as pointers because pretty much in arrays pointers are interchangeably used in C. So channel list index, you're gonna access this channel, the corresponding channel. So it will see whether it's a receive or sent. You can actually see that in the channel.h definition is, I think, is sent flag or something like that. So it will determine the direction of the operation. And then, whatever you have chosen, you're going to return in selected index. So now there is another field in each select T structure is data. So for input, it is going to be used as the input parameter for send, or it can be for receive, it will be an output parameter. So that's the message that we have received. So it's depending on direction, it will be either used as an input or output. So let's suppose we have this operation, select channel, receive on channel A and send on channel B. So we must perform exactly one operation, right? So what will happen? So what if channel A has data? Then we have to retrieve data from channel A. So that's a receive operation from channel A. So if channel A is empty, we cannot receive anything from channel A. But let's say channel B is not full. Then we can send to channel B because we give an option. So we say either this operation or that operation or another operation, so on, right? So if we cannot complete on operation on channel A right away, but we can complete another operation on channel B, we should complete the operation on channel B at that point. So that means we have to send on channel B. So now let's say channel A is empty and channel B is full. Neither of this operation can complete, right? So neither send or receive. So we have to block. So that's how select works. So let's say we have channel A and channel B. So we want to do receive from channel A and send on channel B. So receive from channel A, we have two elements, right? We can take one element from here. Okay, we took one element. Then another receive channel A, send channel B. Again, we took one element from channel A. By the way, there is a tie between channel A and channel B. We also potentially can complete an operation on channel B, but we probably gonna break this tie based on the order, right? So if channel A comes first, then we wanna do that as the first operation. And only after this, we'll try channel B, kind of as a fallback. Okay, so then we have select channel A, receive channel A, send channel B. Now the buffer is empty. So we can no longer receive anything from channel A. So we have to send on channel B. So we will send one extra element, so that's going to be channel B is now full, right? Okay. So we were able to complete the channel B operation, but now another select comes. Channel A and receives channel A, send channel B. So now we cannot perform any operation because channel A is empty and channel B is full. So now it's going to sleep. Okay, so then another thread comes. It will do a send operation. Again, it can perform a select operation as well. And through select, it can do some send operation. But let's just for simplicity assume it's a regular send operation, just a simple send operation. But again, send can also come from another select. Just keep that in mind. So thread 2 is going to do send on channel A. So that means now we have an extra element in channel A. So at that point, thread 1 wakes up. And it says, okay, there is something in channel A. I can get this element from channel A and proceed, right? So receive from channel A. Another select. Again, we have to wait until maybe, let's say, somebody receives something from channel B. Again, let's say it's thread 2. And it can be also select operation. Doesn't have to be a simple send or receive. So we receive from channel B. At that point, we have taken an element from channel B. And this will wake up because for that one, it didn't matter whether it's channel A or channel B, as long as any of them is available, we can proceed. So that will wake up, channel B is now available, we can send channel B, and that's it, right? So again, it gives an option, pretty much select is saying perform this operation, or this operation, or this operation, or that operation. So whatever you can do without blocking. I mean, if you have to block, right? So, but otherwise try to do it without blocking. Okay.
Like, there are two different channels, so you have to.
Yeah, so that's the tricky part, right? So we'll talk how we should wait, because we only have semaphores in each channel, but how should we wait and select? Yeah, it's a good question, right? So we'll talk a little bit about it. Yeah, so this is the trickiest part, by the way, of select, right? So because you have to somehow wait on multiple channels. Yes, so okay, yes, so but okay, let's see how we can solve that problem. So the key challenge here is that we wait on multiple channels. Remember, we cannot have any global variables, and in channel, can I actually insert anything, right? So to channel, probably not, because I have to receive from channel A or from send to channel B. I mean, I cannot even put any mutex or condition variable or or semaphores directly to this channel, because one select is doing channel A and channel B, another select is doing channel B and channel C, another select is doing A, B, and C, and so on. So how are you going to wait? You have the semaphore condition variables in each channel, but you cannot wait on multiple semaphores on condition variables. You cannot just say, or wait on a semaphore from channel A or channel B or something like this. That's not how it works. You can only specify one semaphore, one condition variable. So this is why we need select, right? So why we need to select in the first place. So how can we store this variable with channel, right? Can we store a semaphore condition variable with a channel? Can we? Well, let's say I have select channel receive channel A, send channel B, another select maybe receive channel B, send channel A, another select channel B, channel C, and so on. Can I store this, this condition variables or semaphore inside the channel? Probably not, right? So it doesn't make too much sense. Yeah, and also, so no, variables are related to multiple channels, so it doesn't make sense to keep it inside this channel. But can I, where else can I to store this condition variable? Global? No, because that will wake up everyone, right? That will wake up, all selects. You don't want to keep global variable. Yeah, any other options? Okay. Well, yeah, by the way, before we, so this is something I wanted to mention. For select, what kind of version of, you probably don't want to implement send and receive, which you have already implemented. So what kind of version of send and receive you can use for select? You can use the non-blocking version. Yeah, you can use the non-blocking version of send and receive until you check one channel, you check the other channel, check the third channel, so on, right? And then let's say you've checked all channels, you cannot perform any operation, and then you have to block. But you cannot block, like loop it, like you cannot just busy wait. You have to block at some point. If you check that, okay, all channels, I cannot do any operations on any of these channels, I have to block. So what can I do, right? So, okay, so I think it's a good point that we can use non-blocking version, right? So that's what I wanted to also mention. So please use non-blocking version for send and receive, well, when you use select. But then you still have to block eventually. You still have to block eventually if none of this operation is available. So in other words, select will internally call send and receive non-blocking version, but eventually, once we scan to all channels, we have to block, right? So what do we do? What if we just use a local variable inside select? Just on stack variable inside select. So pretty much what we are going to do. Yeah, let's see. Pretty much what we are going to do, we're going to have select. So we're going to have select. And let's say in select up, we will have local SEMT, semaphore or something like that. So we'll declare this variable on the stack. We'll do some init, of course. Eventually, we're going to do some destroy. So it will only exist for the duration of select. Only for the duration of select. So once select is done, the semaphore is also gone. So then what we are going to do, we need to let the other side know that there is a semaphore like this, right? So and I'm blocked on the semaphore. Please notify me when you have some element available. So let's say I'm about to do the send operation and select. And I realize, okay, I cannot do this but I'm requesting any receiver that comes on this channel to notify me to do some post, right? So effectively. So what I can do in the code, you will find linked list.c and linked list.ah. So that is a double linked list that you have to implement. Pretty much the same way as you did for project one. And just you are given a template to implement these functions, and just follow that template. That will help you to integrate this linked list in the in select, right? So you only need it for select. You don't need it for the basic version. So implement a linked list first, and then once you implement a linked list, what you're going to do is you're going to register for every single channel. Let's say you're performing an operation, right? For that channel, maybe channel 0, channel 1, channel 2, and so on. Maybe this one is receiving, this one is sending, and so on. You're trying to perform that operation. So one possibility is that you're gonna register the semaphore all these channels. So you're going to go for each channel, you're going to maintain for each channel, you're going to maintain 2 lists. One is for receiver lists, maybe receiver list, and the other is sender list. Probably want to have some urexes for those as well. Maybe some urex like lock, receiver lock, sender lock, something like this, right? So please do something like that. Yeah, but it's, I'm not going to specify exactly what you need to do for synchronization, but, probably something like this. So you're going to have receiver list and sender list. And that means if I'm performing a send operation on this channel, I'm going to go to this channel and say, please add me to the receiver list. So whenever there is a receiver has to notify me. So if I'm doing send, that will go and add my semaphore, a pointer to the semaphore, to this list. So effectively, we have a linked list of pointers, right? And each of these pointers is going to point to a semaphore. So this is one select operation has one semaphore. Another select operation has another semaphore. Third select has third semaphore, and so on. So for every channel, we're going to maintain 2 lists. One is a receiver list and the other is sender list. So if I'm doing send operation in select, I'm going to register myself in the receiver list to the opposite side. So now some other receiver, let's say it's a receiver for simplicity, but again, it can be another select. It doesn't have to be receiver, like send a simple receive operation. But let's say it's a simple receive operation. So the simple receive operation will go to this receive list and notify through some post all readers that are registered in this receiver list. So I have received an element, so I'm ready to send. So I have to wake up, right? So I have to wake up this select operation. So all semaphores that were registered in the receiver list will be woken up. So you have one select, maybe another select, yet further select, and so on, right? So you can go through the list and do some post. Yeah, by the way, think about whether it should be just one thread that needs to be waken up or all threads that needs to be waken up. Then I guess that will depend on your implementation. Whether you need to do some post for every single thread that is in the linked list or one thread, right? So yeah, this is something to think about. We want to make sure that no wake up is lost, right? So it should be, so that I think that is important, right? Okay, go ahead.
So we have one semaphore for select function.
Yes.
But then each channel in the channel list is like, so each thing in the channel list is either send or receive on a channel, right?
Yes.
And so we're using.
So this, first of all, to clarify, channels still have the semaphore send, semaphore receive, logs, everything as usual, right? But then in addition to it, it will have 2 lists. One is receiver list and sender list. And then this select will register its semaphore in that list. So that means list was initially empty. but then I added the semaphore 1, right? Then another select added semaphore 2, yet another select added semaphore 3, and so on.
So we have to add that semaphore in each channel.
Yeah, we add a pointer to that semaphore. Remember, we just need a pointer to the semaphore. And that's going to be a list of pointers. Okay. Okay, so yeah, just a list of pointers, and you know, again, think careful whether you want to wake up all of this semaphores or just one. It depends on your implementation. So another thing to keep in mind here, this semaphore only exists for the duration of select. So that means once I call end the select, I'm going to call sem destroy. So the semaphore will not exist anymore. So that means it shouldn't be in the list anymore. So eventually I have to unsubscribe, right? To unsubscribe. And again, you want to get a lock while you're doing it. You probably want to do receive a lock and send a lock. So make sure you do that. You unsubscribe eventually. But when you unsubscribe, there is one tricky part when you do sem post from this side. So you're iterating through the list. And let's say you found some element. And let's say if you just immediately unblock after this, then what may happen is that you found this semaphore in the list, and then you, let's say, unlocked. Maybe by the time sem destroy will already be called, right? So on the other side, and it will destroy the semaphore, because that to unsubscribe, we have to get a lock, maybe receive a lock, you know, unlock. But if you have unlocked it, maybe it potentially will unsubscribe it and destroy it. So one critical part is that you want to do sem post while holding this lock. So that will guarantee that this element still is in the list. Because to unsubscribe it, you have to get a lock. So until you get a lock, you cannot unsubscribe it. So that means you cannot call destroy also. So make sure you do the sem post. And I'm talking about this one in particular case, not in sem post in general, right? Not sem post for the basic version, just for this particular case. When we iterate through the list and we have to do sem post, you're holding the lock for the list while you're doing sem post. Because otherwise, if you're not holding the lock, the moment that you are about to execute sem post, this element may disappear from the list. Sem destroy is called, and semaphore is no longer exists, right? So you want to make sure that semaphore exists while you're calling sem post. So you still want to make sure this this thing has not disappeared. So and to make sure it doesn't disappear, you hold in the lock. That means it will not be able to unsubscribe it. And if it's already not in the list, that means it's already unsubscribed, then you will not do sem post in the first place. So it's either in the list or it's not in the list, right? So by doing this mutual exclusion, either in the list, and you kind of holding off, requiring that to be still in the list while you're doing sem post. So you cannot call unsubscribe here, or it's no longer in the list. That means you're not going to call sem post at all, right? So for that particular element. So yeah, but you cannot unlock it while doing sem post in this particular case, because otherwise it will disappear and destroy the semaphore, and that will be bad. So that's one tricky part I wanted to also mention. So you want to implement this double linked list. You want to implement this to you want to implement two lists, I guess two separate locks, or maybe at least one additional lock that should be separate from buffer. So make sure you create some extra locks for these lists, because they have to also be modified in mutually exclusive manner. Okay. So using the list, we can let the sender and receiver know about this semaphore. That's how we solve this problem. So again, just do a step by step, implement a linked list, make sure it's correct, double linked list. You know, when you implement select, you have three distinct phases. One is registering the semaphore, the other is actually reading, perform an operation, then unregistering the semaphore. So that way you will avoid any kind of lost notifications, you know, any kind of problems like that, right? So first register the semaphore, then you check all channels, then you unregister all semaphores. I mean, you unregister this semaphore from all lists. So remember that send and receiver just need the pointer to semaphore. So that's why you're keeping the pointer to the semaphore. So what about multiple simultaneous select calls? So again, this is why we have a list, right? So that means it's not just one semaphore, but multiple semaphores we can keep. So additional things, you know, why use a semaphore versus conditional variables for signaling? Well, I guess there might be multiple reasons, and you know, one reason I think conditional semaphores actually easy because just you want a one pointer, I guess, and just you know, with conditional variables you have murex and conditional variable itself. I guess that's a little bit tricky, but you know, also about missing signals. Think about missing signals. So I would recommend to implement select through semaphores. I mean, I would not say that it's not possible to do it with conditional variables, but I would recommend to implement with semaphores. I think it will be easier. So it's up to you to decide whether the basic part will be implemented through the semaphores or conditional variables. So I personally implemented it also through semaphores, and I kind of gave you a hint how to implement close. Even though we don't have a broadcast, we can still implement something similar for semaphores. But you know, for select, I guess you would probably want to use semaphores. So either use conditional variables for send and receive, but use semaphores for select, or use semaphores everywhere. That would be my recommendation, I think. But again, I'm not insisting on this. If you can find a way to implement it properly in conditional variables, that's totally fine. So but I mean, again, it's very tricky. It's very tricky to get it right also sometimes, right? So because you want to make sure you don't have any race conditions if you implement it with conditional variables. Okay, so wake up one of all select functions. So that's again something to think about, whether we want to do some course for all select or for just one select. You know, it's can be a little bit tricky because yeah, so think a little bit. It depends on your implementation, right? So it depends on your implementation. But you can potentially wake up everyone, right? So it just depends on your implementation. What if a channel is ready? I mean, all select, all registered selects. You don't have to do just one. So what if a channel is ready right before you make a local variable visible to the channel? So yeah, so think about that, right? So this local variable is semaphores. So the channels are ready before you make it visible. So before that, so that may already did some post on it, but or like already, in fact, I didn't even see that variable in the list when it scanned it. So what happens in that case? But again, as I said, probably want to check it once. Probably want to call a non-blocking version of send and receive before you're gonna go to sleep, right? So yeah, so this is how you're going to avoid this race condition. But before this, you must register, right? Remember, because your assumption here, you registered your semaphore. So then you do maybe last check, right? So I'm just going to go and check whether there is anything available there, right? And if there is nothing available, I'm going to exit. I'm going to be, sorry, not exit, but will block, right? So, but I already registered my semaphore before that, so that any future notification that will come, I will get a notification for that. So I will wake up, even if like maybe some post arrived before some wait. But I have to register it before that, right? So please make sure you register before you actually check the channels. This is why I said it's important to have three phases. You register, you check channels and block, and the first phase is when you unregister semaphores. So again, it depends on how you add channel, but if you have these three different phases, you shouldn't have that problem. So what do you need to do before or after you modify access channel data? Again, think about this question, right? Just think about these questions carefully, right? Also, there is some, commands, GDB commands, just review those. I think you have already done this assignment for GDB, but, for debugging, it may be useful as well. Again, we're going to use GDB if we need to debug it. You may also use, you have to also use WallGrind and other tools, right? So please make sure you take advantage of those. Yeah, so again, this is heavily used in the Go language. Like we are just implementing it in C, and this is pretty much to kind of as an exercise to make sure you know how to use how you use semaphores or condition variables. Yeah, so please get started. I highly recommend to get started this week, at least to get some questions, right? Because you may plan to work like over the Thanksgiving break. It's up to you. I mean, pretty much Thanksgiving break is a bonus week for you, right? So, but if you have some other priorities right now, you may finish other assignments. But I guess in any case, it's important to ask questions first, right? So because you may already get some questions. So the way that you want to, I guess you want to have at least first step in this problem, right? So you want to look, okay, what kind of questions I already have? So let me ask these questions right away. So that means, okay, then I can say, okay, other things I more or less understand. Okay, I can do that later. But it's always a good idea to have a look, maybe not finish that part yet, but at least have a look and get some questions so that you can ask them right away. Because typically, until you actually get started, you don't know what your questions are. Only when you get started, you get some questions, and then I guess after this, it's just a matter of implementing or debugging.